Alrighty, guys, welcome to day 2, okay? I'm gonna be going over basically this whole entire page today, and then I'm gonna ask you to graph, I think, 4 sine or cosine functions for homework, all right? I will also be posting an answer key. But before I actually get to this, what I want to just go over real quickly is we're gonna be graphing these just like we have been graphing parent functions in the past. So if you remember, right, we needed to know like the critical points for y equals, let's say x squared, okay? So for sine and cosine, you need to know a couple things. So for sine, you need to know, right, that if I'm graphing, okay, the parent function, unlike with our other functions where there was 3 critical points, now there's going to be 5 critical points, okay? Those are gonna occur at the quadrantal angles, okay? So pi, 3 pi over 2, and 2 pi, right? Usually we're gonna be graphing in radians, so you remember those are my radian measures, okay? And you're going to kind of unwrap the unit circle, which I'll quickly sketch here, okay? So this, on the unit circle, this would be 1, 0, then 0, 1, right? Then -1, 0, and then 0, comma, -1. So if I go at 0 radians, right, sine is the y coordinate on the unit circle. So therefore my output, right, will be 0. So y coordinate. Then this will be 1, then 0, then -1, and then 0 again. So then when I go to sketch sine, okay, and I start at 0, pi over 2, there's my 5 critical points, 3 pi over 2, and 2 pi, okay. I'm going to start at 0, then I'm going to hit my maximum of 1, then hit pi, then hit my minimum of -1, and then come back because it's a periodic function around the whole entire circle, which I've unwrapped here, to create my nice sine curve. So it should look like this, yes? And that's over one full period. So for sine, right, the domain is always -infinity to infinity. Your range, okay, is going to be from your min to your max. So your minimum is -1, 1, because we haven't changed the amplitude, all right? And then your period is always 2 pi unless you've stretched it or shrunk it, okay? Or shifted it, which we'll do later on, not today. And then our amplitude, right? The height here is just 1 unit above and 1 unit below, so it's always positive, so our amplitude is 1, all right? Now for cosine, we're always gonna have our same critical points, right, for the x values. So we're gonna use our quadrantals, and 2 pi. But now for cosine, when we look at the unit circle, we're gonna focus on the x coordinates. So that will be 1, right, then 0, then negative, just kidding, 0, just kidding, -1, I'm crazy, then 0, and then +1, because this again is a periodic function, so we're back at 1, all right? So then when we go to graph this guy, I'm gonna graph just one period, all right? This is gonna start at 0, right? Then we have pi over 2, pi, 3 pi over 2, and 2 pi, all right? We're gonna now start high, so see the difference. Here we start at 0, right? And what I'm gonna start calling as your midline, okay? Here I start high at my maximum, then I'm gonna hit 0 at my midline, go down to my minimum of -1, come back to my midline, okay? And then hit my maximum again to create the cosine curve. So the cosine curve kind of looks like a nice smooth, not straight lines, they're curves, right? Valley, okay? Whereas the sine curve literally looks like a wave, okay? And always starts at the midline. So that's really important to remember the general shapes, just like we do with any of our parent functions, all right? So domain, again, is negative infinity to infinity. Range is, right, from our minimum of -1 to our maximum of 1. Period, there's been no changes to that, okay? That should be 2 pi, and then our amplitude is just 1, all right? So that, if it helps you, you can write that down yourself and have that as a reference, but that's super important to know, okay? Now, I'm gonna use these ideas to now graph some transformations. So if you take a look at day 2 on worksheet 6-6A, okay, the third page in the packet that I gave you, or the front of the second page, we're gonna graph these just like we've been graphing regular old functions like parabolas, right? Cubics, square roots. If you take a look, this is my basic parent function, right, of a parabola, y equals x squared. If I were to graph y equals 3x squared plus 2, I hope you all recognize that that 3 is going to be a vertical stretch, right? And all, right, my whole entire function is going to be stretched by a factor of 3. And then this plus 2 is going to be a vertical shift up by 2. Okay, we're going to do exactly the same thing, except we're going to do a 2a sine function, all right? So when I see this, I'm thinking the parent function is going to look like this, all right? But we'll talk about what values we'll actually graph using the parent function before. But now I have some numbers, right? So this 3, just like it did here, is going to stretch, right, our sine curve and make it taller, right? If you remember from your homework yesterday, that's really my amplitude, isn't it? It's going to make it taller. So this has an amplitude of 3, all right? Then this plus 2 is going to take this whole graph of sine, this little sketch that I have, and shift the whole thing up. Basically, it's going to change your midline. So now you're going to have a midline, or a sinusoidal axis, that's a fancy word for it, of y equals 2, okay? Now, what the heck does this look like? Well, I'm going to take this whole entire graph and shift basically this axis up to y equals 2. So I'm going to draw in a new axis. Now remember, we've done this before. I make this dotted because it's not really part of the graph, but it helps me to give the graph shape, okay? So I have a sinusoidal or axis or a midline at y equals 2, okay? Then I'm also going to create kind of a roadmap for how I'm going to sketch this graph by using that 3. I know my amplitude is up 3, right? That's the height of my curve. So I'm going to draw a dotted line 3 units above my midline. I'm going to do the same thing below because that's my minimum. So I'm going to go down. So this is at 2, 1, 0, and then down to -1. So this guy is what, 2, 3, 4, 5. This happens at 5, right? My lower boundary, okay, or roadmap is going to happen at -1, all right? Now, I know from looking at my sine function, right, that when I start at 0, right, at 0 radians, and I go up 2 pi over 2, then I hit my midline, right, or 0 at pi, and I go down to 3 pi. At 3 pi over 2, I go down to -1, and then I come back to 0. That's my sine curve, okay? So I'm going to do the same thing, except I'm just going to shift it. So I'm going to start, usually I would start at 0, but I've got a new midline. Then I'm going to go up at pi over 2 and hit my maximum, which would usually be 1, okay? But because I've stretched this by a factor of 3, it's now 3 units above my midline. Then my next critical point is pi. I'm going to come back to my midline for that. Then 3 pi over 2 is when I'm going to hit my minimum, right? Usually that would be -1, but I'm going to hit my lower part of my roadmap here. And then I'm gonna come back at 2 pi, right, to my midline. So my sine curve looks like that, okay? Now again, everything happens for these curves between my roadmap, okay, within there. The middle line is always my midline, okay? It's like my 0, all right? Now, domain is all, right? Real numbers are all degrees or radians. Then my range is literally the maximum and the minimum using my roadmap. So that's gonna be from -1 to 5 inclusive. My period we said is 3. That's my A value, right? My coefficient, all right? And this is going to be, just as an FYI, we'll get more into this, but this is kind of our standard form for a sinusoidal function. And when I say sinusoidal function, I just mean a sine, a cosine, a tangent, okay? We're gonna only focus on sine and cosine. You'll graph these next year, all right? So A is my amplitude, okay? That's my vertical stretch or shrink, if you think about this when we're doing our functions, all right? So they just changed the word, don't ask me why, for when we talk about sinusoidal functions. So that's my amplitude, all right, that's 3. And then the number here, that plus D, okay, that plus 2, that's your midline. That's your vertical shift up or down, all right? Now, notice I have not changed anything about my period. I've not done anything horizontally. Don't worry about B or C right now. So that means my period is just 2 pi, just like we talked about with our parent functions, all right? That has not changed. Now, on your homework, they ask you to graph 2 cycles. You only need to graph 1 for me. This is fine, okay? You could continue this curve if you wanted to, okay, past 2 pi, but you don't need to, all right? So that's 1 cycle. We've filled out all our characteristics, right, our domain and range. That's what I'm gonna be looking for from you on your homework. Now, our next one, okay, is gonna be y equals -1 minus 5 cosine of theta. So you might want to think of this, right, in this order if it helps you. This is your, if you remember, that's our midline. So that's the first thing you should always graph. All right, that's your midline. So we're gonna start there. Oh, -1, just kidding. That's my middle of my graph, okay, my curve. That's like my new 0, all right? Then this 5, okay, is my amplitude. Remember, amplitude is always positive, okay? So from the midline, I'm gonna go up 1, 2, 3, 4, 5 units, which is a 4 on my axes, right? And then from my -1, my midline, I'm gonna go down 5, 1, 2, 3, 4, 5. So that's gonna be at -6, okay? So usually I label, right, my roadmap here. So my curve is gonna be between these 2 boundaries, if you will. All right? Now remember, cosine looks like a valley. So these are our parent functions, all right? So usually I start high, okay? Then I come down to my midline, hit my minimum, hit my midline, and go to the top. Now, what's a little bit different about this one, and you'll have one like this on your homework, it's not gonna be a valley, it's going to be a peak. Why? Well, if you look, can you see how we have a negative in front of here? If there's a negative in front of your function, that means we have a reflection over the x-axis. So normally with cosine, I would start high, but I'm gonna reflect this over my midline, right? Because that's my new like x-axis, my new 0. And I'm actually gonna start low. Okay, so you start low, then at pi over 2, you're gonna hit the middle, right? Oop, just kidding, don't be tempted to graph that at the, on the axes. You're gonna hit your midline. Then at pi, we're gonna hit our maximum, because again, this is a peak, not a valley, because of the reflection. Then at 3 pi over 2, we're gonna come back to our midline. Again, you might be tempted to go to the axes, make sure you're at your midline. And then we finish our full curve, our full period at 2 pi. And then we come back here, okay? So my cosine curve, I'm not gonna go outside my boundaries. So I'm gonna hit my minimum there, hit my maximum because of the reflection. And then graph my reflected cosine curve, right? Again, the midline has shifted it all down. It's my new 0. The amplitude you can see, right, is a full 5 units. So that's my amplitude from the top and the bottom, right? If I measure it from the midline here, this is 5 as well, okay? My domain is all real numbers. My range, again, you can pull it right off your values, is going to be from -6 to 4, inclusive. Your amplitude is 5 because that's the coefficient to the cosine function. And then my period, again, we have not stretched this, right, or compressed this, or shifted it at all. Okay, so there's no change to the theta, so it's just regular 2 pi, okay? So your job is to graph 4 functions. I will post an answer key. Please check your answers against that. It'll contain all the information that I'm looking for you to give me when you're graphing sine and cosine, and hopefully it all goes well. We will be doing more of this, so if it's a little bit tricky, please feel free to comment, okay, on the discussion board or email me, all right? And again, I hope you guys are doing well, and I will speak to you soon. Thanks.